Kia ora tato. Thank you for your patience. I'm Heather Lewis, I was just introduced, and yep, I work at Evaluation Associates. I'm currently quite involved in mathematics, particularly in accelerating learning. Robyn, my colleague, who's unwell today but would be here otherwise, she and I have developed today's workshop based on some work that Pip, Robyn, and I have been involved in actually in the accelerated learning modules, which we're going to introduce you to today. Together with, I'm also one of the two national leads for the mathematics PLD for years 0 to 8 that is being sort of rolled out, I suppose, as workshops across the country at the moment. And the final thing I'm involved in is the year 7 and 8 in a teacher-led trial for mathematics tutoring. So you may have been a little bit of media hype about that recently. So we've been supporting those year 7 and 8 tutors to accelerate learning over 12 weeks to enable those learners to access the phase 3 curriculum. That has really informed quite a lot of what I'm going to do today, because the first 12 weeks is just finished, and the whilst we haven't got the evaluation yet, the early indications are that those students have benefited hugely from this kind of accelerated learning. So without further ado, I will bump on and just introduce the goals of today for you. So hopefully we'll be able to reflect on the difference between accelerating learning and remediating, which we refer to as gap filling. Hopefully you'll be able to describe an acceleration framework that you could use in teaching and learning, and identify those key teaching strategies for pre-teaching and scaffolding, which leads to enabling students to access the correct content for their year level. And we're going to outline some targeted supports on Taharangi that have been developed to accelerate learning. Okay, so this is an often misused, well, not misused, but confused term, because I know that particularly in the secondary sector, acceleration often refers to students who are achieving well above curriculum level expectations. However, I've just got the actual quote from the website around accelerated learning there for you to have a look at. So that's the clarification. So when I'm referring to accelerated learning throughout this workshop today, that is what we're talking about. And again, what is acceleration? Well, often it's students actually speeding up, because that's what acceleration is. It's about, you know, a faster paced learning trajectory. But often to do that, students actually have to slow down to rebuild some conceptual understanding, and also change direction, because their thinking or their conceptual understanding has gone off piste, and so some of the accelerative strategies bring them back in line with those concepts that we're trying to really embed in those learners who are struggling. We've drawn a lot, and we have in the past, through programs for students. If you've heard of Accelerating Learning in Mathematics, ALEM, and MST, Mathematics Support Teachers, that's still a contract that is the Ministry funds, draws from Susie Pepper Rowland's Learning in the Fast Lane, who explains the difference clearly between acceleration and remediation. So the idea of reteaching students, we're rejecting that and going into an idea that we work from strengths-based approaches. So we find what the students actually can do and use that as a basis to build their strength and their confidence and conceptual understanding. So remediation looks backwards, and if you engage in remediation, students really catch up to where they actually should be. I've got a link in this PowerPoint to Chapter 1 of Learning in the Fast Lane that explains it much more concisely, well, much more fluidly than I ever would. It's a very good read. So on the screen now, I've just got Susie Pepper-Rowland's sort of table to talk about the differences between acceleration and remediation. And she identifies those 6 key areas of self-efficacy, basic skills, prior knowledge, learning with relevance, connecting learning to the main class learning, and that idea of fast-paced direction. So what you'll notice there is that acceleration is reliant heavily on building students' motivation and confidence. It is about giving students a high challenge that we scaffold carefully so that they can meet that idea. So high expectations teaching is front and foremost when we think about accelerating learning. And that table is a direct copy from that chapter 1 of Learning in the Fast Lane, which is linked there in the previous slide. In that chapter, Susie Pepper-Rowland goes on to describe an acceleration framework, a framework to guide teaching learners who are struggling with whatever it is that's at hand. So there's the first step, generating thinking and curiosity, articulating learning goals clearly, then scaffolding essential prerequisite skills for the learning ahead, paying attention to new vocabulary and reviewing prior vocabulary. And I was delighted to see that our new maths and stats curriculum has paid strong attention across the phases to the vocabulary and language that students need to develop. Then we take the students straight into the concept that they should be able to access at their year level, and all the time conducting formative assessment to make sure that the students are maintaining that momentum. Let's walk through that framework then. So there were 6 steps there, and I'm just going to walk you through those steps. So the first step is generating thinking, purpose, relevance, and curiosity, using contexts that are relevant or that students may be interested in. And so I've got an image on the screen there, and the question I would pose my students would be, what do you notice and what do you wonder? So I'll give you a little pause there to perhaps put in the chat what you notice, what you wonder. Agree with you, Jen. I don't like the holding anything. It's like, it looks like it's photoshopped. So an image like that will provoke students perhaps to notice a pattern and raise a powerful way of students to learn about multiplication. I am primary trained and I've taught from years 1 to 8, and developing multiplicative thinking is really reliant on students seeing area models and arrays like this. So I think this sort of image, or anything that's rows of trees in an orchard and other array models, are really, really powerful, especially for students who are struggling with multiplicative thinking. Yeah, my question as well, how long it would take to eat one? Not long, but it would probably take quite a while to eat all those. Cool. So really this whole step 1 is about getting kids actually thinking about the context and the problem at hand, and giving them time just to process what's going on when problem solving. Obviously, it will foster motivation if the context is interesting enough for the learners. And the amount of times I know students come out of a maths lesson or learning mathematics and say, I don't know when I'm ever going to use this again. And so it's just like building that idea that mathematics is around us, and you will have need at some point to use mathematics. See? Okay, the second step is really setting goals and tracking progress. And we've guided the tutors and teachers to go to the curriculum, look at the sequence of learning statements and the progressions to help plan individual pathways of progress with students. The curriculum is really clear now on how to really identify and define particular learning sequences that the students may need to focus on. Sorry, my screen just froze for a second there. So we'll enable you to identify the expertise, knowledge, and skills students already demonstrate. So that's really important. Don't assume anything. Students may know stuff that's just been hiding away in their brains. And focus on the end point. This is where we're heading for. We're on a journey now, and we've got, this is where we want to get to. So students know the end point. They're not just, driving along a meandering pathway with no end in sight. For you to identify what big ideas need to be taught first and fast. What is it that will really, really unlock this for those learners? And having something visible and often co-constructed with students can really help them get there. Involving them in the goal setting and their progress and celebrating success regularly. And one of the ways to do that is to make the learning visible. How well can they articulate to themselves, their peers, anybody around them, what they're learning and why? And so having those sort of individual learning pathways can be quite helpful. So once we've set those goals and made that learning visible, you can see there on the right-hand side, those pictures are ideas of concept maps that you can use sort of for the group of learners or for the whole class really, actually. And so students can really clearly see what it is they're learning, where the connections are. Those arrows will show those connections to other ideas. It can be quite powerful, especially for struggling learners who may have retention and memory problems. So step 3 is where we go to scaffolding prerequisite and essential skills. And scaffolding is an intentional and strategic approach, putting supports in place for those gaps that you know are there from the past, so they have this sense of success. It can take some of the stress out of learning new concepts. And hopefully with the right sort of scaffolds, the students will get more motivation and confidence to challenge concepts. So some examples of scaffolding that we draw from are things like your Freya models, if they haven't got fast recall or quick recall of multiplication facts, then give it, if we're solving that donut problem of how many donuts there are, then give them some scaffold with those times table charts, because what we're interested in is seeing if they can solve that problem. We're not testing their quick recall of basic facts. So that's sort of like a cheat sheet, by chunking learning, using graphic organizers, text marking, and finding examples and non-examples can be very, very helpful as well. So that one in the middle of one half gives some examples and non-examples so students can see clearly what it is and what it's not. Okay, and so again, making mathematics visible with multi-dimensional thinking. It's those ideas of think boards and Freya models. So we can see it, we can see the equation, we can see what it looks like in different contexts. We can see how it relates to the commutative property and see that, for example, 3 times 5 is also repeatedly adding 3. So just those, I mean, that area model for multiplication can be very powerful, those sorts of models, and just students to see it multi-dimensionally. Step 4 is about vocabulary, and as I pointed out earlier, the list of vocabulary in the curriculum is really, really helpful and a powerful new addition, particularly to, you know, our very junior teachers in the junior school. There's I counted them as 384 words in the mathematics in phase 1. So in the first 3 years of schooling, you know, students are expected to master and use those words. And I noticed that equation was listed as year 1. So our students should be coming through, if we're paying attention to the curriculum, with a far greater command of mathematical language. And we found, particularly in the past in ALM and MST, that it often unlocked a lot of misconceptions once students actually got to use and explain using mathematical vocabulary. So one way of doing that is to introduce this idea of a tip chart, or term, information, and picture, and students can construct that for themselves. And there's an example there of rotation with a representation, so that if I have to look at that word, I can see quickly what it means. I can remind myself. And the final step, once we've set some goals and done some good strategic scaffolding, dipping into this new concept. And if we want students to solve rich tasks or investigate mathematically, many students need a lot of support to do that. And so I know in Tahurangi now, the maths investigation cycle, which I think is somewhat of an adaptation from the PPDAC cycle, but it's certainly a mathematics problem solving cycle, can be a really helpful tool to help students work through unpacking problems. So you see there, that's the picture there of the cycle as it goes, with students making sense and planning their approach, taking action and convincing themselves and others. So explicitly teaching those skills will be critical for those kids to actually be able to apply those skills and knowledge that they've just built to solve problems. So the idea is to spend some time explicitly teaching problem solving and really enhancing and giving students the confidence to communicate these skills by supporting them to share and explain their reasoning and collaborate with others. The resource comes with some guiding cards that students can draw from, with those nice questions when they're making sense of a problem. Do they understand all the words? Can they visualize the situation? And would a drawing help solve it? So some really nice, helpful little prompts, I suppose, for when students do engage in, you know, a complex or challenging task. And the final step, which isn't really final, it happens right throughout the whole of this accelerated learning cycle, is to conduct formative assessment ongoing. So finding opportunities where students are explaining their thinking will give you guidance on where to perhaps pause and reflect and reteach, or where you can see students thinking is consolidating and you can move on at a faster pace. Building those norms, classroom norms or group norms, where it's safe for students to take risks, to explain their thinking, will be critical to be able to conduct that assessment. Because until you know what the students are actually thinking, you can guess and address that, but it's much more powerful if we actually do know exactly what to pinpoint. So how can you accelerate learning? So what we've proposed is providing short, focused, pre-teaching mini lessons. You can do those 5 to 10 minutes before a lesson or through additional dedicated support. The use of concept maps and tip charts, visuals, diagrams, and equipment, particularly equipment, sentence starters, and graphic organizers will help to achieve that. And also scaffolding during the lesson. Once those misconceptions occur, we don't want to wait for the students to fail. So having already up our sleeves some of those ideas for pre-teaching or scaffolding is really, really helpful. So in summary, this is the framework I've just walked you through: generating thinking, purpose, relevance, and curiosity. So beginning with success starters, engaging tasks, estimation tasks, and ensuring that students have got the tools to discuss and have conversations and explanations. So scaffolding, that can be just how to decode a problem, making connections across key ideas, using equipment and visualizations. One of the things that came out of the maths trial for the year 7 and 8s, the student voice was very strong in the fact that the materials really helped them understand the concepts. And building memory for fluency. This idea of front loading, giving kids what they need just in time, just before the lesson starts, addressing those misconceptions, that strategic development of that vocabulary, and those key concepts that are needed for right now. And building self-efficacy, ensuring you're building that growth mindset, that it's okay to make mistakes. It's actually, that's how we learn. And providing opportunities where there isn't necessarily a correct answer, but there is an accuracy. So we could have an open-ended or numberless word problem where the students come up with the numbers themselves. Therefore, they can then aim for accuracy, but have ownership of the problem themselves. And building mathematical identity. And certainly in the year 0 to 8 in the primary sector, we strongly emphasise building partnerships with whānau to support that learning and to also ensure that they are part of this learning pathway with their kids. Okay, so scaffolding, and this is just a little wee dip into what we could do through this idea of enabling prompts. When we've got learners that we know are struggling with particular concepts, how we adjust learning to ensure that they have got access to the concept being developed. So I'm going to show you a rich task called the Magic Donut Tree. And this task is probably, I would be teaching this at around year 3. So an example. So the donut tree was magical. Every day, the number of donuts in the tree doubles. And here's my problem. The Kai was having his birthday party on Friday, so the family decided not to pick any donuts off the tree till then. So it's Monday, and on Monday there were 3 donuts on the tree. Your job is to work out how many donuts there were by Friday. Remember, the tree was magical. Every day the number of donuts on the tree doubles. So I'll give you a pause to think about what the mathematics is there. What we'd expect our learners to be able to do. And then think about those students who may struggle. They may be able to double the 3 and get to 6, and maybe double the 6 and get to 12, and may come a little unstuck then. But we do want them to learn how to double and double, scale up. So I could enable it by saying that there was 1 donut on Monday. And so how many would there be by Friday? And therefore the learners who can't get through that problem because they haven't got the necessary skills multiplicatively to get there still have success with the same concept of doubling. And I can spend some time with those learners to scaffold their confidence to work with those bigger numbers. And I may have some learners who need a little bit of enrichment. So I can just up that problem to Saturday or Sunday. So they're getting to solve that problem with larger numbers. And ask, can they keep the pattern going? And how would they be able to do that? And I could provide some sort of scaffolds that get them started so that they could see what was happening visually and then fill in the rest of the problem to support their thinking. So these ideas and ideas like that, we have written some guidance and also a series of lesson exemplars, I suppose, on Tahurangi in an accelerating progress in mathematics and statistics area. And what Pip, Robyn and I have done is given some guidance to teachers and then provided a couple of examples at each year level across the breadth of the mathematics curriculum. So not just a number, because that's often emphasized far too much in primary level, but across statistics, geometry, algebra, and measurement, so that teachers can pick these resources up and look at how a particular concept, there's one that's on perimeter and area, how if students are struggling with working out the relationship between perimeter and area, how we would spend 10 minutes a day before that unit of work comes up, scaffolding those students to develop the prerequisite skills of perimeter and area in order to solve the problems that the class is solving. So rather than putting those students into a lower ability group and only giving them low-level perimeter problems, we want those learners to access the learning at their year level. And so we've had to give a little bit of additional time and support to do that. So these are constructed as mini lessons that would last between 10 and 15 minutes across 3 or 4 sessions to guide and support those students to access the learning that's coming up. And each example is sequenced to scaffold that conceptual understanding. It clearly shows the 4 elements of a comprehensive teaching and learning program that is outlined in the new maths and stats curriculum. And they're weaved together with these carefully structured sessions. So explicit teaching is the scaffolding parts. And in all of them, we've paid a lot of attention to ensuring that students have access and do engage in rich tasks. And there is a promotion of student discourse, of students explaining and justifying their mathematics. With positive relationships with maths is highlighted as how we would ensure that students are building that positive relationship. And so they're available on Tahurangi. But what I'd acknowledge is that acceleration is access, it's equity. If we don't accelerate student learning and we continue to remediate, we're only going to increase the tail of underachievement. So if we do take this strengths-based mindset and provide those just-in-time supports for learners, that are embedded in daily teaching, that are strengths-based, and are targeted and efficient, then we've found, I suppose, through ALM and MST, and now with this 12-week tutoring trial, that this can work. Motivation grows, confidence grows, and success breeds success, I think. And those are references from the work that I've pulled in to develop some of this, a lot of it from Peter Sullivan and Smith and Stein. I didn't put Susie Pepper Rollins in because she's referenced right at the start. Sorry, she should be there at the beginning. And so I will stop sharing now and open, see if there's any questions at all.
If you have questions, maybe you can put it in the chat. So we'll have some few minutes for that now. Or you may unmute yourselves and ask the question, please.
Recommend the whole class do the mini lesson or just those who need it. And I think they're really targeted more at the students who need it. But the whole class may well benefit from revisiting some of those core concepts anyway. So I guess, you know, the unhelpful answer as always is it depends. Yeah, I think the practicalities, especially in the secondary sector with timetabling, is always raises questions. And again, I don't have an answer. I wonder if Pip, are you able to contribute to that? Because I'm, you know, at primary we've got the flexibility of the day, and I know secondary don't.
Yeah, I guess in secondary it probably has to be a lot more constructed, and it could be that if you know something's happening coming up in the future, there may be opportunities within your lesson to do a little bit of that pre-teaching. But I guess the challenge for us always is that, and I guess my knowledge from back in the days with the ALM was this was in addition to the classroom teaching. So we don't want to be taking away from that classroom time. So that's where the challenge comes in. You know, is this something that maybe we could look at doing in a form time space or something like that? So yeah, it's a real challenge, but I think it's one that's worth grappling with, because that idea of students being able to access the year level learning that they're at is really important. And I think, you know, if we're all, you know, in theory, if we're all working on that, you know, if I'm a year one teacher and I'm making sure they're all working at year one through to year 6 and year 8, you know, hopefully by the time they get to secondary, we won't have those big tails that we have. I mean, that's the thing that we're, you know, secondary teachers, we really appreciate everything our primary and intermediate colleagues do. And, you know, the more support they're getting there, so they're coming into high school. But high school still has a job to do. So, you know, Alan, you might have some ideas about things from your perspective as well.
Yeah, many of the teachers here would have their ideas. When you go to senior level, there are standards to fulfill, but in the junior level, we're quite flexible. So it's always a question of, do we ensure that the students learn, or do we want to finish the curriculum? I guess there is a compromise there that we'll have to meet up. We want to finish the curriculum, but at the same time, we want the students to learn. If I may, we are now 12:39. We'll finish in 5 minutes, is it? Okay, I just would like to give my own reflection, and I know many of you share this. My take now, Heather, into my big take for me, from what you've shared, is know where the students are at and build on them. And we should build strength-based mindset as teachers. I like also when you say make students learning visible. And this can be made visible. We can support them by supporting them with concept map, as you've mentioned, and ask students themselves to build this concept map in a way we know what they know. I also like your idea of multiple representation of problems, not just the 3 times 5, but 3 times 5 can be seen in different ways. I love the idea of scaffolding, but scaffolding will also depend on how you'll be enabling prompts. So for us teachers, we need to learn as well how to ask the right questions at the right time to the right students. I like also when you said that we have to build a positive relationship. We want students to build a positive relationship to math. And I think when you mentioned celebrating success, even small successes that are celebrated would mean a lot for the kids. And to make, as you mentioned, to make math more meaningful, it should always be related to where the students are at and their context. Some of you may want to add that. Yeah, before the final karakia, I'd like to take advantage of this time to thank everything, acknowledge everything for coming into these sessions. I learned a lot. Now, it sometimes affirmed that what we do in the classroom, and I've learned a lot from Heather. Heather, thank you for the time you spent. It's Saturday. We should be doing something with our family, but thank you very much for spending some time with our teachers. Thank you. So we pass it on to you for the final karaki.
Okay, so karakia whakamutunga. Tēnei rā te whakaari ake educate ata wānanga. Tōna Māori no runga, no rangi, no raro, no papa. Tēnei te Māori o te maturanga ka whakatakina ake kia wātia a ine pukenga hui e tai ki e.